Yes, hello. It has been a while, but some weeks are just more busy than others. Today I have a small window where I can squeeze in a tutorial and we will look into, wait for it, texture coordinates. It sounds very boring, but it is not, trust me. We will use Blender to learn about texture coordinates, and we will build a very simple scene with some very simple objects just to learn how texture coordinates work. And we will start with the basics on how to manipulate. This is something I want to learn myself for a long time. And we will use the shader editor for it, which has this node system where we can plug in all kinds of aspects of materials. And it reminds me very much of the node system in Grasshopper Rhino, the parametric modeling tool. Sadly, I'm not doing a Grasshopper Rhino tutorial today, but if you want to learn Grasshopper, I want to highly recommend a new channel of my brother from another mother, Leonardo Gindry. He started a new channel about parametric design and Grasshopper. I hope I pronounced it correctly. Parametrizado. So if you want to learn Grasshopper, this is definitely a channel to watch out for. He knows what he's talking about. Again, watch that space. See, he has only 3 videos and already 90 subscribers. So Leonardo, good luck. I hope you have great success with your new channel and live long and prosper. Now back to our parametric node system in Blender. I would just restart a new file just so you can follow along. Let's move that to 1. Yeah, let's move it to 1. And object, set origin to cursor. And then we will also put a plane. I think it's good to explain the texture coordinates with a plane as well. No. And let's also put the monkey head. Suzanne, let's put Suzanne here. And I want to make sure that the head is the same size as the cube. What I mean by that is same bounding box. So if we look at here, the visibility of the object, if I look at the visibility of the object, I can turn on bounds. You can see the bounds, and because I want to demonstrate something. So I want to make this 2, 2, 2, and then object, apply. You can do it with Control A, apply scale. So now scale is 1 to 1 to 1. 1, 1, 1, 1, 1. That's the scale, and then also for the cube. So they have the same. The bounding box has the same size as the cube. Let's keep it like this. Now let's have a. I think that's fine. Let's keep it like this. A bit lighter, and we move into cycles. I wanna use cycles for this. Cycles and Eevee, and I learned that just recently that you can actually. Let's make this a sunlight. Strength is 1. And what I learned recently, the material shader is actually the Eevee shader, and you have the options here to turn on the scene lights, and then you have the Eevee shader, and you can switch here with set, between rendered and Eevee, between cycles. Now we're in cycles, and material preview, which is basically the Eevee shader. I can show you. This is very much true. So if I go here in Eevee on the viewport shading, then now this is the same as the material preview. It's pretty cool. I didn't know that. So I didn't know that before. So, and then we will just divide this window here, and we switch to the shader editor, and now we add a new material. We will just kill this principal shader for a while, and we input the node input texture coordinates, and we will today only look at the generated texture coordinates and how to manipulate that, and we look at the other ones another time. They are worth to look in separate videos. Another thing I want to tell you what I'm using here is the node Wrangler. You can turn this on by going to preferences and type node and just activate the node Wrangler. It has some very cool features. One of them is, for example, to switch between nodes and the output. So it's better I just show it. So if I use Ctrl Shift and click onto that node, it automatically creates this node in between, which is basically just an emission shader with a color and the strength. 1. Now if there's for example another, let's try to have this one here. If any other node in here and I want to test this one, test something here, I can do the same. I can just go Ctrl Shift and click here, and then this is connected here. So that way you can switch between outputs very quickly. I don't need this. There's another default command which is very useful, is to mute stuff. I can mute things. For example, I have a color or a texture. Let's say I have a noise texture in between here, and I want to mute that, and just then what I can do is I just click M here, then it's muted. Then this just actually interestingly does not. So if there's, for example, a math node, let's see if this changes anything. I will explain in a minute what it does here. But if I want to mute that works here. It works very good. So I can mute that, and you can see on the red line it just goes through without any calculation in between. So we will also make Suzanne the same material. Let's name that material texture coordinates. Too long. Doesn't matter. It doesn't really matter. For sure, there's a better convention. Anyway, so if we look at the definition here, what the generated texture coordinate does, it says here, automatically generated texture coordinates from the vertex position of the mesh without deformation, keeping them sticking to the surface under animation, ranging from 0 to 1 over the bounding box of the undeformed mesh. See texture space for more information. I went here. It's not very well. I mean, I appreciate, of course, the whole manual, but I think it needs more explanation for sure. What does it mean? A texture creates a texture coordinates from 0 to 1. Where does it start? The bounding box starts basically in the corner, in the left lower corner, and it basically follows the same system as the world coordinates. So if you look at the coordinates here on this icon here, then you see, and this is very good to remember actually, is that x positive values go to the right, which is here red, and then y is green, and z is blue. And the same is actually shows here, that these colors representing the coordinates, or how the texture would be distributed, start from here, from this point. Red goes into the x direction to the right from 0 to 1. Set from 0 to blue up, from black to blue, 0 to 1 up, and then y from black to green, 0 to 1 backwards in the y direction. And you can see that they are all, looking from above, they have this, they are all mapped the same. And if I change if I scale them, they also keep the distribution always mapped to the bounding box. So I can do the same here, for example. It's always sticking to the surface in the same way. It's not what it doesn't do is, so for example, if I change this here, and I will, let's see, if I would, for example, rotate this with a fall off, that will not, you see that it will stay within, the texture doesn't rotate with the object. That's not what it does. Okay, let's stay here. I hope it makes some sort of sense. So if we would mark it up, let's mark it up. Let's use a grease pencil. X here from 0 to 1, and then we would have Z from 0 to 1, and Y from 0 to 1. Battery was over on the camera. What else can we do with this? So let's try to manipulate the distribution of this here. So we go in here, we can use the vector math node, and there's a difference between the math and the vector math node in that case. So let's start with the vector math node. So in order to, for example, move the origin within here, we can either use the add or the subtract numbers. For example, if we go now to 0.5, then you can see that here the vector was shifted by 0.5 in that direction, and also on the other items. So 0.5, if I do this, then you can see it was now shifted here, and this became completely black because the origin now is in the center. And let's put this here because I think it's more clear. And now if I do this, then we now it's correct. Then now our origin is now inside that cube. Now because we shifted the whole thing, now we can't see the full extent of from 0 to 1, because we only go from 0 to 0.5 from the center of that cube. So let's add a multiplier. We can just duplicate that, multiply by 2. So we create the whole range from the center point to the boundary of the cube. Let's try to add a translucent a volume shader, just for fun. Let's do that. And we've used the vector we have so far and put it here, the density, and we use that, and you can see that you can see the density shows now the area where we have cloud particles, or I don't know how to call that. It's actually here creates weirdly, it's recreating a cube, although there's no cube. It's very interesting. If we mute that here, what's happening? Okay, not much. If we mute that, then it's kind of equally distributed, interestingly within the bounding box of that objects. Anyway, we can go back to this later on. So what else can we do? We can use a function called absolute. So I copy this again, Control D, put this here and also here. I want to use this function here. It's called absolute. And what it does, it's create absolute numbers, means there are no negative numbers anymore. As you can see here, it's basically mirroring everything from the center point. So if I mute this here, you can go back, mute, unmute. You can see that. Now we can, what else can we do? We could split, for example, the x, y, and z coordinates. Separate x, y, and z. So now we only see the x coordinates split with the absolute, so basically mirrored. If I would go here back to 0, I would just start here at the beginning. And if I would not have the absolute, if this wouldn't be there, if I mute this now, and if I push this into the center, then it will just look like this, black and white. So with the absolute node, I can basically mirror the vector, the mapping. Let's turn this back on so you can see the difference here. Yeah, I can separate this, and then with, for example, the where is it? Converter smooth maximum. Let's try maximum. We can combine values again. And then we need to shift control just to get this thing here. It combines, but it also creates this color ramp, or like a gradient from the center towards the outside. And the other node, which is the maximum smooth, helps to kind of smooth out this transition. That's all I can explain. That's how I can explain it to you. I don't know how otherwise I can explain it to you. That's what it does. The more you play with it, the more you're gonna understand what it does. So to make it more obvious, we can also either here create a color ramp and play with that. It almost looks like a Maki roll. Play with it. This is one way to do it. Or instead, we can also use another math node, which is the to the power. That also works really well because it creates a very nice transition. Because we at the moment move only within the XY coordinates. That's why you can see it from the top but not from the side. And to change that, to make it three-dimensional, completely three-dimensional, we can copy this here. And I want to keep it separate because I can control it better. So I could actually directly go into that. I could go into here, basically. I think that should work, but I lose this ability to kind of smooth it out. So I'll keep it like this. So in order to also add the set value, we can do it like this. We can take this here and add this here, and then go into here. And now we need to remove this one. And you can see that there is something black inside. We can't look into it now, but basically with here I can control how smooth that's, how much I want to smooth it out. Let's have the same values here. And with this one I can control the strength. I can make it smaller and bigger. And let's have a look how that looks in the principal volume shader. Yeah, here it doesn't, on this 2D phase it doesn't make much sense. And also maybe we need to look, yes, cycles. Let's kill this here. And you can also go here into the negative area. Then you actually concentrate your cloud or whatever you want to call this in the center. Yeah, and then we can also add all kinds of stuff. So for example, we can add a texture, noise texture. We can add a noise texture. No, of course not. We need to have a math node here, and we can then subtract. So we need to put it here, and then we need to of course put it back here into the density. Now it should actually work. Yeah, then it's more about playing around. So you can play around with here with the power. If we have less, it's less dense. So for example, if we try to, that could work really good. Maybe a bit less. So more. Make it 2.5. Yeah, it's really a matter of playing it. And maybe it's maybe it also works better if we first put so we go directly into here, and then we change the. That might work better. And then maybe it's easier to work with the color ramp. Let's try the color ramp for this. Yeah, I forgot something, of course. When you want to show something, it never works. It's always like that. And we might go back even to the power node, because it seemed was kind of more elegant. So let's go back here. We had the power. Here it made sense to actually subtract here from the noise. Yeah, you always need to play a bit. I can see where I want to go with this. Now I'm just playing around. But somehow I worked with texture node, and then suddenly I have a cloud. Interesting. Don't need this anymore. It's all clouds now. And I was thinking, okay, how can I make this more interesting? What if I increase this here now? Now you can, for example, scale this. We could, of course, have more objects like this with the same material. Oh, not this material, this one. No, they all look the same, but we could also either scale them, but they still look very much the same, you know. So what we could do now is instead of and for sure you can still play a bit with how that cloud looks like. Maybe it's a bit too defined. So that's one way, but then they're still the same. They're still similar. So, but that's a way that you can play with the shapes a bit more. And now what we can do in order to make them all different, we can add a object node, object info, and that creates a random number for each object. We could place that here into scale, but the problem is it's I need to add a math node here again, just to control the output a bit. So now every object I'm creating here is different. yeah, as you can see, there is still a lot to improve, and also the rendering created some artifacts. The denoising didn't work in some areas, didn't work properly in some areas here, you can see that. But on the other hand, in some areas it's pretty decent clouds, I would say. Here you can see that the fog was hitting the shape of the cube, so that's why it didn't work. But yeah, but then again, there's some areas they look pretty convincing. So yeah, that's texture coordinates. Not that boring after all. And there's a lot of other things we can do with it. But yeah, that's the first video about shaders, and hopefully there will be more.